Beneath the icy surface of Jupiter's moon Europa lies one of the most intriguing mysteries in the solar system, a hidden ocean that may harbor conditions suitable for life. NASA's Europa Clipper mission, launched in October of 2024 from Florida, is poised to unlock these secrets, making it one of the most ambitious planetary missions ever undertaken. With its unprecedented capabilities, Europa Clipper aims not only to further our knowledge of the cosmos, but also to answer a fundamental question: could life exist beyond Earth? Europa Clipper's primary objective is to assess the habitability of Europa by investigating its icy shell and the ocean beneath it. The mission is designed to perform nearly 50 close flybys of the Moon, gathering critical data to better understand its structure, composition, and geology. The spacecraft will fly as low as 16 miles above Europa's surface, each time observing a different part of the Moon. Europa is widely regarded as one of the most promising places in our solar system for the potential existence of life. This little world, so far away from the Sun, somehow harbors vast amounts of liquid water under its thick ice shell, perhaps twice the volume of all Earth's oceans combined. This makes Europa Clipper's mission not just an exploration of a distant moon, but a quest to find the conditions that could foster life in environments far from our planet. Europa Clipper is the largest spacecraft NASA has ever built for an interplanetary mission. With a height of 16 feet and a span of more than 100 feet when its solar arrays are deployed, exceeding the length of a basketball court. The spacecraft is a powerhouse designed to operate in the challenging environment around Jupiter. One of the key engineering feats is its massive solar panels, which will collect sunlight for power, despite being more than 5 times farther from the Sun than Earth. Weighing over 7,000 pounds without propellant, the spacecraft is equipped with an array of scientific instruments that will probe Europa's surface and subsurface. These instruments include high-resolution cameras and spectrometers to map the Moon's surface, an ice-penetrating radar to search for pockets of water beneath the ice, and a magnetometer to study the ocean's depth and salinity. Additionally, Europa Clipper will carry a thermal imager to detect warm regions that could indicate recent water eruptions, as well as sensors to analyze Europa's thin atmosphere. Europa orbits Jupiter within a region of intense radiation generated by the gas giant's powerful magnetic field. To withstand this radiation, Europa Clipper's sensitive electronics are housed in a specially designed radiation vault. This vault, made of thick titanium and aluminum walls, will protect the spacecraft from the damaging effects of high-energy atomic particles. Without this protective shielding, Europa Clipper's systems would degrade rapidly, compromising the mission. The Europa Clipper mission, launched on the 14th of October 2024, will take about 5 years to reach Jupiter. The spacecraft will rely on a series of gravity assists, slingshot maneuvers around Earth and possibly Venus, to gain the speed needed to cover the 1.8 billion miles between Earth and Jupiter. Once in the Jupiter system, Europa Clipper will begin its detailed exploration of Europa. To allow the spacecraft to gather comprehensive data on Europa while minimizing its exposure to Jupiter's intense radiation, it will in fact orbit it, albeit at a relatively safe distance, and make repeated flybys of the Moon. This might sound counterintuitive, but proves to be a better strategy than orbiting Europa itself. During each flyby, Europa Clipper will investigate the Moon's icy shell, its subsurface ocean, and its tenuous atmosphere. Europa's subsurface ocean is the main focus of the mission. The ocean is believed to exist between the Moon's rocky mantle and its icy crust, which may be several miles thick. Europa's surface is marked by cracks and ridges, likely caused by the stretching and flexing of the ice shell, as it is tugged by Jupiter's immense gravitational forces. This tidal flexing could also generate heat in the Moon's interior, keeping the ocean beneath from freezing solid and possibly providing energy that could support life. In addition to searching for the ocean, Europa Clipper will also look for signs of plumes, jets of water vapor that may be erupting from the Moon's surface. If the spacecraft is lucky enough to pass through one of these plumes, it could directly sample the water and determine its composition, offering valuable clues about the chemistry of the ocean beneath. These findings could help scientists understand whether the ocean contains the necessary ingredients for life, such as organic molecules and chemical energy. Although Europa Clipper will not land on Europa or search for life directly, it will provide the most detailed data yet on the Moon's habitability. By studying the ice shell, the ocean, and the geological processes at work, the mission will help scientists assess whether life could exist in Europa's hidden depths. If the conditions are right, if there is liquid water, a source of energy, and the necessary chemicals, it is possible that microbial life could thrive beneath Europa's icy surface. In the end, Europa Clipper's mission is not just a search for life, but a journey of discovery. A voyage to a frozen moon, where, beneath layers of ice, the faint stirrings of an ocean whisper of possibilities unknown. And perhaps, in the stillness of those icy waters, we may find echoes of life.